Hi, everybody. My name is Vasir. So I'm working at NIBIO, and I would like to talk about one of our projects, SmartPlanter, which is enhanced dibble bar for precision planting. And I would like to talk about how far we get with the development. So the presentation is built up as you see in the screen. I will talk about a bit background, how we come here, some requirements, what we think is needed for this such a device, and then I will show what we've done over the years with multiple device generations, and then I would also show some results from our field trials. The basic idea of this SmartPlanter, which is actually a dibble bar, come from Precision Project. Rasmus earlier mentioned this in his presentation, that we know there is a big trouble in our forest regarding root and bud rot, and we need to handle it or address it. And one way is to know where is it, and then we have to act according to where is it located, and for that we might need plans. And to carry out a plan, we need to know where are we in the forest, and we have to know how and where to plant and what. So this was the beginning of the development, and then in the project we get one prototype, and then after the project ends, Smart Forest, our currently running large project, took over, and this development became part of it. And in one of the work packages, we got the chance to develop it further. As you see, the advantage of our project is that we have multiple direction over the value chain in the forestry, and we have plenty of partners from the industry and also other companies supporting this process. So we have a chance to have impact with this development in silviculture. So I talked about it. This is our first image about it. So this is how it looks now. But what we need to have this device? First, we need a real-time positioning, so we know where we are and what is the where is the seedlings will be planted, and then we need to support the planters on the field. So we need mapping. This it should be pre-prepared. So we show it to the operator or the planter. Then we show what and where to plant, and also we help to guide on the field, because okay, there will be a border, but we won't know that, okay, is it 2 meters, 3 meters, 20 meters from us? So we also need to give information and notification that, for example, a border is crossed. And in the meantime, we record the data, and then also this device should be robust enough. As it was mentioned, we have military-grade criteria for such a devices, so it should withstand weather and everything. This is a quick overview what's in the box. So we need GNSS services. So we have the satellites up there, and then we have a correction signal from the system, and the device itself is located as you see here in the image. So we have a GNSS module in the box, we have a radio module, mini PC, we have a screen on the smartphone or whatever screen, and then we have a base station to have local data if something goes wrong. That was the original idea, that what we would need. And according to functionality, we can have a plan. We have stands and plots, and we can define, okay, this area in this stand is for one species, then the other is for other one. So for example, if we know that here is the root rot is very active, then we probably shouldn't plant there Norwegian spruce. So, but if you don't have this information, we won't act, but this is our attempt to address this. For the planters, we can show the species ID, a number, where is it exactly on the map, where he was. And actually our planters make fun that, okay, we have 250 seedlings in the belt, and will I meet the number on the screen? And then they registered the seedlings, and it was they were really happy when they have the same number. So that was a good feedback that they like to use it, and it's kind of gamification also. So it could help us to have support from people who actually will use it later on. So we have three generation, but different versions of this device. So what I showed earlier is for the later generations. So when we started the project, we have everything out of the box, but they were big, and we need to put them together. And this was the smallest box what we could find and fit everything. And the whole backpack is around 5 kilo. So that was our first version, and then we went for smaller version, and then even a standalone version later on. So the backpack was used like this, and yeah, we got constant complaint that, okay, it's moving around, it's heavy, but we said, okay, but we need the good GPS connection, so we have to have the antenna up there. It was good. We got good connections, and we also had the screen, which was good, served the purpose, but we prayed not to rain because it wasn't really waterproof. And it was also cables to the PC. That was the method, how could we put together. And we managed to get the site planted, and we tested the concept. Later on, we got the data out of the recording. We could conclude it was a successful field trial by that time. And we recorded all the traces, and then we say, okay, here is a plant, and here is one. So the exact accuracy, where was the plants, it was a bit uncertain, because we haven't got any registration from the planter that when he put down the seedlings, and then we realized it afterwards that, okay, we need it. The post-processing give some okay results, but of course, who can tell that what is the precision from this image? But later on, we address these obstacles. So we came up with version 2.0. The whole backpack fit into a box, which is approximately like this size, and we put it on a dibble bar. We added a button on the top. You can see this white box on the top and an antenna, and then we said, okay, we need a smartphone because of the functionality, and then we showed the display on the mapping on the smartphone. One design issue that we connected to the box and from the phone, and it doesn't have internet, which means that everything went offline. It was a bit difficult to get the data out of this box. It was so compact. It's okay, where to put my USB stick or my Ethernet cable. So we have to think a bit, and then we came up with the latest iteration, small software updates, and then we got our standalone dibble bar. Why is it standalone? Because in the previous versions, we needed a base station to get the proper correction data for the GNSS. But with this, we get internet connection, we get direct CPOS and correction information from the authorities. So with this single device, we can record each plant, and it became more scalable. In the process, we added a camera in the top. It's another small white box. And this means that we can even record where we planted. It's around 1 square meter. And we can analyze, okay, how good is it planting? What does the the planters does. Did he choose the scarified place for this location where they needed to plant or not? And then everything is connected to a cloud service. So then we have data upload automatically coming from the device. So it's became more and more comfortable to use. The cloud service is provided Oracle, and we are developing not just the infrastructure for this device, but also many other projects is connected to this service. And our aim is to be able to connect all the different parties along the value chain. For example, we can use from the cloud the harvested data we uploaded during harvest, or we can use drone data what was done weeks ago, before the planting, or the planting data from our device can be used in later for site treatments. So since they are everything in the cloud in one location, the data exchange became much more simpler. We can manage who has access, how. We can provide information for companies. We can control the devices we have, and we can also monitor real time that what's happening with them. If everything works in the office, then we can go to the field. We conducted 3 major campaigns in the development. The first one was with the backpack, as I mentioned. It was about how to, so it was more a silvicultural experiment. And then we tested the performance of the devices. The second experiment was with the base station configuration, and the third one with the standalone one. We got good results. We not just tested the location, but we also verified with the standalone TopCon RTK GNSS results, and we found that they match quite well when we have a good signal. And the map also showing that at some location there is obviously missing some seedlings, and this means that there are some residual and ponds or rocks, which is rather common in Norway to have rocks. So lucky you to not have it so much. So we matched the data points. It was a bit time consuming, so we still improving in this process. And here is some numbers for you. I put together some information. So what we see here that our device was tested over 1,000 points, 1,000 in one set and 350 in another second set. And we found that in a good time we got fixed signal, and most of the time we got at least RTK float signals. The first experiment is a very open field, so we got better results. And for example, this 300 set is in a rather closed forest, so we planted in a packet, so we get a bit less accuracy. But in general, we can say that we know where is the seedlings within a 1 meter radius, and probably we will find it afterwards because the distance between seedlings is a bit more. Our plans includes to increase the numbers of these units, improve the signal quality, and also improve the data processing and the cloud services we can provide. And also with our partners, we want to integrate this data in their forest management frameworks. Thank you very much for your attention.